Now in this question we're asked to solve the simultaneous equation 3x plus 2y equals 17 with 2x minus 5y equals 5. Now I've picked this example to demonstrate the next type of simultaneous equation where neither the x terms nor the y terms are the same. So how do we do this? Well, again, like all simultaneous equations, let's make sure we start by numbering the equations. Now if we decide that we want to eliminate the x terms, they've got to be the same. But we can clearly see anyway that they're not. So what we do is we find a number that 3 and 2 in this case go into. And preferably it's the lowest common multiple of 3 and 2. The lowest number that 3 and 2 go into. And that would be 6. And we can bring this up to a 6x if we decide to multiply both sides of this equation by 2. So what I'm going to do is tell the reader that I'm going to take equation 1 and I'm going to multiply it by 2. So I'm going to double this side and double this side of the equation. So it's going to keep the same balance to the equation. So if I double the left hand side, I get 2 lots of 3x is 6x, and 2 lots of 2y is going to be plus 4y, and 2 lots of 17 is going to be 34. Now I look at the second equation and I want to bring this 2x up to a 6x as well. So I can do that by multiplying both sides of this equation by 3. So again, tell the reader what we're doing. We're taking equation 2 and we're going to multiply both sides of equation 2 by 3. So what we get is 3 lots of 2x, which is 6x, 3 lots of minus 5y, which is minus 15y, and that is equal to 3 lots of 5, which is 15. So I have now 2 new equations. So I need to number these equations next as 3 and 4. Now what you'll notice in equations 3 and 4, I hope, is that the 2x terms here are exactly the same, both 6x. So when we have 2 terms that are exactly the same, we can eliminate that term, the 6x in this case, from both equations by doing subtraction, by subtracting equation 4 from equation 3. So tell the reader again that that's what we're going to be doing, and that is taking equation 3, and from 3 we are subtracting equation 4. 3 take away 4 then. So we know that 6x subtract another 6x eliminates it. Okay, we just get no x's, so I'll leave that. And then we go on to the y terms. You've got to be very careful here as usual. Let's just do it over here in the margin. Should be able to do this in your head, mind you, after a bit of time, but we'll just put it over here as plus 4y. Okay, then we're subtracting, okay, don't forget, the next y term, which is minus 15y. So we have 4y then, plus 4y, and we have minus minus, which is replaced by a plus because the signs are the same, and then we have the 15y. So plus 4y plus another 15y is plus 19y, or just simply 19y. So therefore, by subtracting the 2 equations, the x's have gone, but the y terms give us 19y. So therefore we have 19y, and then we have 34, take away the 15, leaves me with 19. Dividing both sides by 19 now leaves me with y equals 1. So now that I've got y equals 1, all I've got to do now is substitute y equals 1 into any one of these 4 equations. It doesn't matter which one we pick, we should always get the same value for x. But as before, it's best to just select one of the equations that you find the easiest to work with. I'm going to go into number 1. Why? Because I don't like minuses. And I certainly don't want to go into equations 3 and 4 purely because they've got bigger numbers in. So I'm going to stick with number 1 in this example. Okay, so let's just tell the reader that that's what we're going to do. Sub y equals 1 into equation number 1 in this case. So if we do that, therefore what we have is 3x plus 2 times y, so that's plus 2 times y, which is 1, and it equals 17. Tidying this up, we then have 3x plus 2 equals 17. Next, I just need to subtract 2 from both sides, so therefore I have 3x equals 15. And then dividing both sides by 3 gives me x equals 15 divided by 3, which is 5. So to summarize, I therefore have x equals 5 and y equals 1. And you can check this value in any one of these other equations and you should find that your answer will agree with the final value on the end here. I'll leave that up to you, but there we go. That's the solution then to our simultaneous equation. Now what you could do is not only just eliminate the x's, but you could actually have decided that you wanted to eliminate the y terms instead. And in my next video in this series, what I do is the same question again, but eliminate the y terms.